Univariate statistics. Univariate statistics means statistics based on a single variable. For example, you might take people's heights or their eye colour. But it's definitely an or. You're only measuring one thing. To make valid conclusions, you need to run large-scale data investigations, which means you need to collect data. Let's just quickly remind ourselves about data. We know that data can be numerical or categorical. And we know that these can be further split. What we mean by primary data is data you collect yourself. Secondary data is data you use that was collected by someone else at an earlier time. So if you get data from the internet, that is secondary data. If you are collecting your own data, you will need to decide if a census or a sample is better. A census means that data is collected from the entire population under consideration. The population under consideration might be adult Australians, or it might be the people in your maths class. A sample means that data is collected from a subset of the population. There are lots of ways of collecting samples. There are pros and cons of each, and we're talking about here whether we take a census or a sample. So a census, remember, is taking data from every member of a population. So it should provide a true measure of the population. Although you should remember that that's always a shifting thing, and if it takes you a long time to collect and process, it may only be a snapshot. It provides benchmark data for later studies because we have that snapshot, and that's how they compare things with, say, what the situation was in 2020 with what the situation was in 1950, because they have census data from 1950. It provides a greater opportunity to get data about small subgroups. When you sample, very small subgroups of a population may not really have their views represented. The cons of that is there can be practical difficulties in surveying the entire population. It may be time consuming. I already sort of mentioned that over here. And it may be expensive. Think about all the paper documentation that goes out for the Australian census. So for a sample, it may be cheaper than a census. It may be less time consuming than a census. And if good sampling techniques are used, it may be representative of the population. But there is always still a question about that. Data may not be representative of the population, especially for small samples, even when you use good techniques. And a lot of research is done into these techniques. It can lead to a lack of information about small subgroups. If you have a tiny group of people within a population and you sample and you maybe take 1 or 2% of the population, you may really not hit some of those subgroups at all. Because of this, it may not be suitable for future benchmark studies because you can't be sure about the accuracy of your snapshot. Inherent in samples is the concept of bias. By not taking information from the entire population, certain measurements or views or opinions may be over or underrepresented in a sample. This can occur even when great care is taken over the sampling technique. There's just going to be some inherent variation in samples. An example would be, take a look around a class that you take where you've got a good number of students. And let's say you're going to survey the heights of the students in that class. And you're going to do this by taking a sample of 3 students. You could, just by picking names out of a hat, end up with the 3 tallest students. And that would give a biased view of the heights in the class in general.